Follow the stuff the students are interested in. So wherever possible, let the students find their own data sets, or even better, record their own data about their own environment in some sense and something they care about, and let them explore, let them roam free. So rather than lock projects down to, you're going to analyze this data set with this question and produce this output and this kind of graph, really give the students room to explore and roam free.
How do we find the answers? How do we communicate them effectively? And more importantly, how do we evaluate the data stories that other people are telling us to make sure they're both accurate and valid? Dr. Linda McIver is highly passionate about this, and she's on a mission to help students understand that harnessing data is a powerful means of understanding their world.
You're listening to the Physics Ed Podcast. For hundreds of ideas, free experiments and more, go to pizzics-education.com.au. And now, here's your host, Ben Newsome.
Yes, welcome again to another Physics Ed podcast. Hey, big week this week. We're speaking with Dr. Linda McIver, who's highly passionate about teaching high school students all about the data. She's built innovative courses in computational and data science for year 10 and 11 students at the John Monash Science School, but now she's gone one step further, and more than just a little bit. She's gone and set up the Australian Data Science Education Institute, where their mission is to empower teachers and students to understand, use, and communicate data in every single context. We're talking science, maths, tech, geography, history, politics, whatever, even English. Data runs our lives, and Dr. Linda McIver very much knows it. So today it's all about the data, as you can very much hear, and I was very, very interested to hear about what she's been getting up to. And hey, by the way, she's actually been nominated as one of the inaugural superstars of STEM in 2017. A highly passionate educator, and certainly one to keep an eye on in the future. So without further ado, let's hear on to Dr. Linda McIver. She's got a lot to say.
This is the Physics Ed Podcast.
So I am the Executive Director of the Australian Data Science Education Institute. It's a new organisation which I've just started up. It's a not-for-profit and a registered charity. And our goal is to get data science into the classroom as a way to allow students to do real projects with actual impact in their communities and build their data science and technical skills at the same time.
So it's a new program, and obviously it can have a high impact. I can undoubtedly see that coming, but where did that come from? And where was this need to go ahead and found something like this?
So I've been running data science projects at my school, the school I was teaching at until the end of last year, which was John Monash Science School in Melbourne. I've been running those for 7 years now. And what we've been doing is in our year 11 computer science class, we've been working with scientists who have computation needs and data needs and who don't have the skills to make it happen for themselves. So I was teaching kids computer science and programming, and they then used those skills to help the scientists do stuff with their data. And then that was an elective subject, and the kids were doing real stuff. So my first class of year 11s did cancer research and actually contributed to my molecular biologist's research. It gave him software that he's still using today, as far as I know. So they made a material difference. Yeah, I know, right? So they made a material difference to cancer research in year 11. You don't get to say that very often.
I know. I was going to say, let's pause on this chat and let's just find out a bit more about that, because I know that everyone in high school trying to teach wants to give kids real life experiences, but being able to genuinely contribute to real research is a little bit rare. How'd you be able to find the person who's prepared to work with them, and then go from there? I'd just love to know how you went about that.
So I was really lucky in a lot of ways, because I went from academia into high school teaching. When I was an academic, I loved the teaching, but I just wasn't as obsessed with the research. So I quit academia and eventually got into teaching at John Monash. And because I had those academic connections, and also because I hadn't been in the school system forever, so I had this different perspective, I guess. I knew that the kids I was working with had strong technical skills, and I knew that there were a lot of researchers out there who didn't have the technical skills or the money to purchase them that they needed in order to do their projects. So I basically put out a call to all of my academic contacts, and I said, hey guys, does anyone have any software that they need, or any data they need analyzed or visualized? come work with us. And the first year I had 2 researchers work with me. One was a marine biologist from Deakin. And we worked with seal data, which was pretty cool. Yeah. And a molecular biologist from the Monash Medical Research Institute by the name of Michael Gantier. And he had enough computer science background to know what he needed, but not enough to do it. And I had 2 extraordinary kids who are not kids anymore. It was a long time ago, but Matt and Chris took it on, and they worked with Michael to work out what he needed and to build the software to do it. And it was a really challenging project, but because they had the opportunity to do something real, they really got into it. They were still working on it the next year, although the assignment was well and truly over and marked. But, you know, they were doing something real, and so they kept contributing. It was fabulous.
Geez, I wonder what they're doing now.
Well, actually, Chris is working on the gravitational waves project.
So you started them down a path.
Well, I think they're pretty much on that path anyway, but yeah, they got some pretty cool opportunities. I just had a bunch of students present at Lawn Genome Conference because they did some work with Dr. Soninka Tyagi from Monash on identifying microRNA and predicting its structure. And they broke new ground with their work, and so they presented it at an academic conference. Again, this was year 11 project work.
That's so cool. And what I love about what you've just done is going, you know what, why don't I just ask people?
Yeah.
It's so simple.
Yeah, it's all come out of conversations. And so this is why I've started up the Data Science Education Institute, because it was great that the kids in my classes had these opportunities, but this is actually not hard to do. You need to give the kids the opportunities. So the point of the Institute is to try to get those opportunities out to all students, not just the kids in my own classes.
Yeah, I bet. And so now you've fully well and truly dived in completely because you're heading up this institute. How many school students are you working with at this point?
So I'm actually working with teachers rather than with students, because there's only one of me. I can't work with that many students in a year. That's the point of the Institute. So my idea is to skill up the teachers, to give them the ability to put these data projects in their classes, to help them find the data sets and help them interpret the data sets, because there's a vast amount of data online, but not all of it is easily interpreted. So sometimes you need someone who, for example, has a PhD in computer science to help you work out the data and help you make use of it in the classroom. So that's my role, is to build those skills with the teachers and then get them to put those kind of projects in their own classes. And it's not just in tech classes, it's in science, it's in maths, it's in geography, it's in enviroscience, history. There's room for data projects in just about any area of the curriculum.
And you pretty much picked what my next question was going to be. I was going to say, because maybe some people might be wondering, hey, maybe this is only for ICT teachers or science teachers. I love the fact that you just said history just then. I mean, how many? What do you know of what projects that have bloomed out of this at this point around areas that aren't as predictable? So if you look for data on a particular topic, there'll be a data set out there that suits that topic. So some of the things we might look at for history is, if you look at all of the documents around a particular era, how many of them actually mention women, to look at gender representation. Or I saw this one cool project a couple of weeks ago at a conference called Kiwi Fu, where these guys actually took Hansard, which is the parliamentary record. This was in New Zealand, and they mapped which topics got talked about by which parties at which time. So you could track over time the interest in topics like housing affordability, or jobs and employment, or the economy, and see which parties were interested in which topics. You could totally do this even in on Twitter or anything like that. Any particular topic where that's trending in any way, you could really delve into it deep.
Absolutely. And, you can track it over time, or you can look at the particular people talking about particular things. It's just the endless scope.
Oh, I bet. And I'm just sort of thinking, it makes a lot of sense what you're doing, working with teachers who then work with their students. Not only do they know their students better, let's be honest, that's 100% the case. Mm-hmm. But it's a force multiplier. And so the people who are rocking up, perhaps it might be potentially a little bit daunting to meet someone with a PhD in computer science education, all that type of stuff. Mm-hmm. what are people's feelings when they come into the courses and the workshops that you're running? I mean, they tend to come from for want of a better term, newbie status, or they've been doing it for years. Where are they coming from?
I'm getting a whole range of people. There's a lot of teachers out there who really want to get into this stuff, who see the potential of it, but don't quite know how to go about it. So I pitch the workshops at wherever you're at. I will go into schools and run a workshop for a particular school group, or I'm running a workshop that coincides with or is part of the CSIRO conference on computational and data intensive science in a couple of months. And the idea there is that you come in with your own discipline knowledge, and I help you apply that in the data science space. So if you've got a geography topic around water, we can look at water quality, and I can find you a data set that will help you find a data set and build a lesson plan around that. So you don't have to have technical skills. We can do this just with spreadsheets and a really basic level of computer knowledge, or we can do it at the programming level if you've got more experience. It's depends where you're up to.
Yeah, I'm actually just sort of sitting here wondering about the gifted and talented, like, the kids in the primary level, like the upper grades. I'm kind of wondering, have you had any connections with those teachers? Because there'll be a couple. I want to just think of a couple of opportunity classes I know right off the top of my bat right now, that I know there are a couple of students there that could totally handle this high school type of headspace. Have you had any interest in that area?
Yeah, very much so, particularly because both of my kids are gifted. So I'm very into the space.
That would run you off your feet, by the way, just as a side thing. Having gifted kids, people go, oh, that's fantastic. No, they're really, really highly intensive kids.
Yes. Intensity is exactly the word. It's absolutely full on, and it's really hard work. And any teacher knows that having a gifted kid in your classroom does not make life easier.
No.
But the great thing about the data projects is that they give the scope for kids to find their own project and really run with it as far and as deep as they want to. So one of the examples I often used for primary schools is, let's do a project based in their own environment. So find an issue that they want to fix, collect some data around it, analyze that data and find out what the problem is, and then develop solutions for it. So, for example, they might want to do a rubbish survey and look at how many of the rubbish, how many of the items are particular, like say chip packets. How many of them come from the canteen? How many of them come from home? And then work that into a whole unit on sustainability and pollution, and how do we tackle this problem if all of the rubbish is chip packets? Well, can we develop some kind of program to encourage people to put their chip packets in the bin, or to use a different distribution mechanism for the chips so that we don't have the packets? How do we tackle this? And then the kids are invested in it because it's their own environment and something they care about.
I love that. And I mean, working locally and having a genuine impact's awesome. And then giving the kids an opportunity to then have whatever their research comes out, or even just helping other researchers, means that they can then impact other areas too. That's really, really cool. I'm kind of just wondering, when you sort of think about all this happening in the data science world, I mean, there is a really big movement, momentum. I mean, it's a little bit cliche, this whole big data thing. When you hear, I mean, obviously you're working with the teachers, but through their conversations, how are the students taking on this, that this data is out and about no matter what it is? Like, are they getting how much data is actually out there, do you think?
Look, I don't think most adults even get that. I'm working in this space, and I'm sometimes really taken aback by the impact of data on our world. And so that's why one of the reasons it's so important to be exploring this from an early age and to really get comfortable with data. Because for one thing, when you're presented with data, someone gives you some stats or a graph, to be able to look at that critically and go, well, hang on, there's no zero on that scale. So that graph is actually really misleading. What you're showing as a really big difference is actually only 4%. To be able to ask those kind of questions, or what was the sample size? Did you interview 2 people for this data, or was it actually a decent representation of the population?
Yeah, I almost feel like every kid should be able to know what a confidence limit is before they leave school, because it actually does matter.
Yeah, it really does. To be able to say, well, my data shows that 100% of people are in support of this law or something. Well, how many people did you survey? It's a really important question.
And how skewed is that survey? Were there a particular user group that took on that survey only, and how did the others not hear about it or hear about it, how they interacted? And then there's a cultural side as well. It's like, oh gosh, it's a minefield.
Yeah, exactly. So
And
even to start having those conversations, to turn the kids into critical thinkers who, when they're presented with stats, actually query them, or presented with a graph, go, well, that's not a valid way to represent that data. The classic climate change graph that allegedly shows that there's a pause in global warming and that, it's flat. Well, that's one segment out of a much larger graph. If you look at the much larger graph, you see that there's an absolutely massive upwards trend, and it's undeniable. So has this data been cherry picked to show us the one bit that looks like it's doing what we want it to do?
Yeah, and that is such the skill, especially when we're able to just critically analyze the papers, the news, the public stuff that goes out on the internet and on the social media. I mean, it's so easy just to be confused by a flashy headline and a highly emotive picture.
Yeah, that's exactly right.
Yeah.
So it's also important that the kids, when they have their own data, when they're presenting information to others, that they're presenting that in a valid way, but also a really compelling way. For me, it's all about telling the story of the data. What can this data tell you? And how can you tell other people that same story and really make them, really persuade them that it's important?
So with the Australian Data Science Education Institute, you're up and running and off you go. What could you imagine you doing in the next couple of years? What are you hoping as an output, as an outcome, as you go along your way?
I want to see data in every classroom, in every subject, and really incorporated into the way we interact with the world. I mean, data is controlling so much of our lives, from the news that we get shown, the people we connect with on social media, all of the internet interactions are so massively data driven, but it's also controlling the traffic lights and the health system and the decisions that get made by politicians and government departments. We need to be asking critical questions of those. And if I have teachers in every discipline using data and showing its connection to their discipline, and students learning to be critical data thinkers and to present their data in valid ways, then that's just awesome. Ultimately, I want to put my institute out of business. I want the school curriculum and teachers to be so skilled they don't need it. So I also want to be changing the way teachers learn to teach, put it into the education degrees and stuff, that data is a fundamental part of all of these subjects.
Absolutely. I cannot resonate with that more highly. We run rapid skill days on professional development, so TPL, and we've always said in behind the scenes, our job is to stop us doing this.
Yeah, that's exactly it.
Yeah, that's really cool. Definitely someone that's, I don't even know how to say it, birds of a feather or whatever it is. It's the same. That's awesome. And I totally agree. And the fact that you're going well beyond, and by the way, hey, well done on being nominated as a superstar of STEM for 2017 by the Science and Technology Australia. Is it institute, organisation? I'm not too sure.
Association.
You think, it's the association.
Yeah.
You think I'd remember? Oh dear. Sorry, guys. but well done on that. And the fact that you're going well outside of STEM, the reality is you're just making T visible in every area.
Right. And, it's also the M, because there's a lot of statistics in data science. So it's the maths in there as well. And, you can build in the engineering if you're actually recording data about your own environment. You could be using sensors to do that. And there's plenty of scope for the engineering. And of course, science is built into all of this. We're asking questions and exploring the world and trying to find stuff out. That's the essence of science.
Yeah, it's fantastic. And I really hope that the students keep on going on. I love the fact that your very first two students right from the start, one's going into some serious studies now. I wonder what the other one's doing.
The other one's doing a lot of stuff in physics. So he's moving into quantum physics, I think. That's Matt. And they're both doing extraordinary things.
And they're well prepared for it. I mean, they saw it in year 11 and now they're doing it in the big bad world of university level, but they were still doing university level stuff in a high school environment. I mean, that's just wicked.
Yeah, it is pretty wicked, but there's absolutely no reason why everybody can't be doing this.
Exactly. Now, if you had to give any advice to anyone who wanted to start students down a data path and they weren't able to connect with you for some whatever reason it was, what would be your advice for at least starting students on that journey?
Follow the stuff the students are interested in. So wherever possible, let the students find their own data sets, or even better, find their own, record their own data about their own environment in some sense and something they care about, and let them explore, let them roam free. So rather than lock projects down to, you're going to analyze this data set with this question and produce this output and this kind of graph, really give the students room to explore and roam free. They often need a lot of support in choosing their question. We did an election-based project one year where we had every Senate vote cast in the 2016 federal election for Victoria. So we had each line of the file was one vote, and every box on the ballot paper, we knew what people had written in that box. This was an amazing data set. But kids would ask questions like, which is the best party? Now, I wish that data set answered that question, but it doesn't. It can tell you who people voted for the most, but it can't tell you which is the best party. And of course, best on which measure is a very fraught question.
Yeah, qualitative versus quantitative.
Yeah, right. So you have to help the kids drill into what questions can this data set actually answer. And then, some need more support with that than others, but to let them explore things that they care about really gets them really engaged.
Couldn't agree more. And undoubtedly, there will be people who want to get in touch with you. So how do they do that?
So the best thing is to leap onto my website. It's ADSEI.org, so ADSEI.org, so the Australian Data Science Education Institute. If you Google it, it'll come up, or you can just email me, Linda@ADSEI.org. Get in touch and let's do stuff. There's a newsletter that you can sign up to on the website to keep in touch with what we're doing.
No worries, and we'll pop that all on the show notes, as we always do, because I love the fact that anyone can be really getting in touch with you. It's irrelevant which education discipline you're actually in.
Absolutely, yeah. There's room for data everywhere.
I'd love to know what the arts teachers would do, because there are data points throughout some of the artistic, the sculptures and the galleries. I guess the mind boggles just what you can actually do with this.
That's right. There's endless scope, and it's just a matter of finding the area you're interested in and then finding a data set that's relevant, and away you go.
Good fun. Well, thank you very much, Linda, for jumping on the podcast. We'll catch you another time soon.
Absolutely. My pleasure. Thanks for having me.
This is the Physics Ed Podcast. We're excited about science. Grab a copy of our new book, Be Amazing, How to Teach Science the Way Primary Kids Love, from our website. Just search Be Amazing Book. It's available in hard copy and ebook. Go to fizzics-education.com.au. That's physics spelled F-I-Z-Z-I-C-S.
Yes, as you could hear, data science is very, very important for all our lives, not just students, and understanding how the data works and how to depict it properly is critical as we move through this century and beyond. Hey, someone else who definitely very much cares about data science and mathematics in general was a previous guest, Steve Sherman from Living Maths in South Africa. He's got a lot to say about this too.
There are some people who use mathematics to defraud the taxman. There are some people who use mathematics in advertising, and they'll say something like, 3 out of every 5 doctors recommend this headache tablet. But the reality is, if you went to 100 doctors and you asked them, would you recommend this particular tablet, you might not get the same stats. So now we start going into a whole thing on statistics and the reliability of that information.
Yes, you can definitely hear that Steve Sherman is a highly passionate educator when it comes to mathematics, so it's well worth your time to jump on into episode 20 of the Physics Ed podcast. Yeah, it's a bit of a while back now, but Steve has a lot to say, and it's well worth checking that out. Even if you heard it before, it's well worth checking out again. And I hope you had a bit of fun listening to Dr. Linda McIver. She has having a lot of fun with the Australian Data Science Education Institute, and I know that she's going to do a big impact for Australia and beyond, without a doubt. Anyway, you've been listening to me, Ben Newsome from Physics Education, and you've been listening to the Phys Ed podcast. We've got more things coming up, so I hope to catch you soon on the next episode. All the best.
You've been listening to another Physics Ed podcast. We're excited about science. Subscribe to us on iTunes to download the next episode as soon as it's released. And don't forget, for hundreds of ideas, free experiments, our new Be Amazing book and more, go to fizzics-education.com.au. That's physics spelled F-I-Z-Z-I-C-S.
This podcast is part of the Australian Educators Online Network. aeon.net.au